Okay, so this is joint work between DLR, German Aerospace Center, and my own company LTX, together with the colleagues. So the credits to all of them. And I'll give a bit of project background, where we come from and what our motivation is. And then we are going to look at the modeling process from the Modelica perspective. And this is more or less an overview of what we do have in our paper, because this is quite long. Then I'll just dig into two topics: assessment of model quality and challenges in the model and data management in larger Modelica projects. And the conclusions and outlooks will be done by Martin Otter. So this new UPSIM project is now running for a year and will continue for 2 new years. It's about unleash potentials in simulation. I will talk about this on the next slide, but it's a EU-funded project, 7 countries, and about 30 partners. So from life science, from automotive, from agriculture, so broad simulation experience in there. And what it's about is more or less the idea everyone is doing modeling and simulation today. And we as experts know that more or less all models are wrong, and we just need to know how wrong they are. But if you're doing this in exchange between many organizations, then you have to have more processes and more metrics how credible these results are. And the UPSIM project has more or less a 3-layered solution approach there, defining more quality measures. It's called here digital twin readiness levels as a buzzword, but more or less saying what can the model be used for in a standardized form, and also continuous collaboration. Like we all started continuous integration on Modelica models, but the question is how can we do this between different organizations and really make it work? And the last part is to make really sure what is the used model and have a unique identifier that we are sure which model is used, for example, for homologation or stuff like that. And in the end, I mean, we all know this digital twins buzzword, but the idea is to have more real behavior in the models, more physical behavior, but be clear what it's able to do, this digital twin. And the nice thing is the main outcomes shall be made available in open access. So if you want to see more about this project, it's upsimproject.eu. And now I come a bit to our view of DLR and LTX, how we see this. And our main idea is here, we work in projects where we use Modelica cross-organization. And this has been done for the last 20 years. Let's say we have a model developer doing Modelica models, giving it to a supplier in a Modelica tool, and then at some OEM, for example, it's used. Now, the main difference since the last 10 years, or since the last 5 years, is that due to FMI, there's a lot of stuff going on, and you cannot see into the FMUs if they are exchanged between organizations. So I'll do just one example here. So let's say we are on the left side, we are the model developers, we're getting some component specs, some system specification, most of the time not very complete, some measurement data, and we build some component or subsystem. Okay, that's all clear to you. Now we build this model and usually we deliver FMUs. Sometimes if people like it, we also deliver Modelica or encrypted Modelica, but most of the time, our Modelica models end up to be FMUs given to some other organizations. And here on the bottom, I wrote a bit the way the files go. I mean, it's trivial, but it's good to see how they do it long way. So we do have our Modelica models in a Git repository. Then it's uploaded to some file exchange server or sent via email. Then it goes into some version control system. The supplier tests the models and gives them in the end to some FMU, to some OEM to do system test. So FMUs and documentation are handed over again to some file exchange server or email, and then maybe again into some version control system. So using any closed system here of exchange doesn't work, because in any step you have encryption and you don't hand over the full documentation. So you will never work in an open source way like you can do with buildings library or something. And I think that's the main part for us of the UPSIM project, to make this work in a nice way. And the good thing is that we do have Modelica and FMI, so we have ways, nice file formats, specified file formats, which we can exchange, but there are clinches in the process, and we want to have these in a smoother way. Okay. So some questions which we usually see. So this poor model developer here has to think, what is the model going to be used for? He doesn't really know in detail. He hopes he does it in the right way. The supplier thinks about, okay, I've done it once now for one project. Can I use this FMU for another OEM project as well? What's really in there? Do I understand what it's doing? And the receiver at the end just sees some FMU. And now then is the idea, oh, we can use it for anything, but we don't really have the spec what's in there in the numerical sense and in the physical sense. Okay, so this was more or less the starting point, this view. And of course, DLR and us, we did simulation projects and saw this view in different industries, aerospace, automotive, rail industry, robots, what you name it. But what we don't see is a public best practice guide for larger Modelica and FMI projects. Like this way we saw now, the file formats are specified, but this way how to exchange the stuff is not specified. And so we plan to do more or less three things. We want to link the specification initiatives in the Modelica Association, because you have to have a view on Modelica, FMI, and SSP at the same time. Sometimes the standard won't do it, then we have to improve the commercial or open source tools. And if tools and standards won't fix it, then we aim for UPSIM reference processes. So the UPSIM project also defines reference processes, and this could also be a way to go. Okay. So our paper more or less went once through the modeling process, and that's why 5 people wrote on it. So from defining the requirements, defining the model and task, really implementing the model, and then calibrate, validate the model, and then at some point use the model. I won't go through all the details of this slide, but more or less the idea of our publication is to really look into the single steps and look what we already did in the Modelica world and what we already have, or maybe is nearly there but not used. For example, the Modelica requirements library, now the results of the Embrace project, to name a few from the requirements part. Or for using the models in the end and receiving them and understanding what's in their Modelica style guides, documentations on the validity range, or what really has been tested and which input combinations have been tested, or in the modeled effects, which modeling detail has been built there. Do we have a dynamic model or a stationary model, or these parts? There's no formal way how to describe it. If you have a good documentation, you find it out. If you have the Modelica model, you can find it out. But if you're stuck to some FMU, then it's hard to find out this information. In the UPSIM project, there's much more work on the actual definition of simulation processes, and that's why I just link here to the credible simulation process. This has been released open source now from the Z-level project, and it will be improved in the UPSIM project. So now a bit into the details where we are going. The assessment of model quality is really hard, and especially it's hard to automate. I mean, usually this is trust in the guy who built the model, and then you know, okay, he did a good job and he had these constraints. But there are some movements. So for example, the EFMI standard goes in the right direction. There you have in the standard written down a tolerance-defined reference results, which you can store inside the EFMU. And when you build the code, then the tools can support automatic test for verification of the generated production code. So this is now for embedded devices, but you could also think about this style for Modelica models, where you say, okay, I tested the model in this way and I store the references and they can be reviewed afterwards if it's still working in the same way. But there's, at least I don't know, an automatic way of doing this reference handling. And The second part is more or less really working on the model quality metrics. This is research work to my impression. For example, how to specify the range of validity and the tested input range of a nonlinear model and the combination of inputs. That's really hard to specify, but if we come up with some basic metrics where we can agree on and have these in the supplier OEM tool chain, it might help. So bottom line, to build credible system simulations across organizations, to have this trustworthy, we need to work on optimized quality metrics. I cannot present them today because the work just started, but at least this is a way to go. And I'm really interested in discussion with other people here. Second part we identified are the challenges in model and data management. This is really the nasty part you have to care about, but as an engineer, you don't really like it usually. But if you wanted to have traceability, who did what when, and the reproducibility, so to be able to reproduce simulations all the time, then you have to care about your assets. I'm not sure I like the word assets here, but I think it's a good description. We always think, okay, we have the equations in textual form, that's fine, but that's not enough. So you also have the system structure. You could use Modelica or SSP for it. You have the parameters to be stored in Modelica or SSP or external files. You have your scripting in MoScript or Python, usually your result files in Mat or CSV, your measurement data, and then your executable models, usually as an FMU. And all the stuff you have to care about and manage. You have to do the revision, version management, and to see what changed from one step to the other of all this bunch of stuff. So one way could be go in the direction of a container format, similar to an eFMU or an FMU, where you can put stuff in. We have the Modelica libraries where we have to put, where we can put resources in, but we have not the one container where we can have a full simulation project in there. So that's a proposal from Thorsten Blochwitz, I think, and it might be interesting to go in this direction. And together with these assets, more or less, we have also the simulation results and the metadata. And there you have many questions you usually ask. So which simulation tool generated the result, and which settings have been used, and which model has been used, and what variables should I look at? So this is also not standardized, in my impression, to find out how has it been done. I put two examples here on the slides. The one is from the Modelica standard library reference results. There we create a creation.txt, which has some of this information in there, just hands-on, not nice, but at least you write down how the result has been generated to compare different Modelica tools. And also there are lots of work now going on in the SSP project with this traceability draft, also called glue particle. There I have one snippet of an so-called STMD file, and there you have links to your models and all the more or less the simulation process. So you can have like this glue particle, in German Beipackzettel, to your model and have it through all of your simulation process. So this is not specific to SSP. It could be used for other Modelica standards as well. So long story short, if you want to be able to re-simulate, then your simulation result should not be just dumped trajectories. You need more metadata, and it's hard to store all this yourself. Yeah. And this was my slide. So now Martin Otter could wrap up.
Okay, very quick, 1 minute. See, so in UPSIM, summarize, collaborate with simulations in order that the simulations can be with qualified metric used in a much better way in industrial processes as it is today. And Model associations should support this with improved standards. Maybe go to the next slide. Leo, next slide. Okay. Okay, here are some ideas about potential standardization activities of the Modelica Association. First of all, standardize the domain of validity of a model, including quality measures. So all the types of models, Modelica, FMI, SSP. So similar as a data sheet of a hardware component, but more. So you have to describe which effects are taken into account, neglected effects, measurement calibration conditions, and where you find where you can reproduce how this model at the end was generated. Then standardize further information that is needed for the traceability and collaboration, the group particle approach that was just mentioned. Maybe use this as a basis for all standards, so also for Modelica models. Then extremely important, of course, when you want to compare or rerun, or you need result file formats. And currently, the CSV format used in the Modelica is really, yeah, just the baddest, the best thing from all bad solutions that you currently have, and we need something better. And it should be possible to use it with cloud services. And one possibility would be eventually, Michael Tiller and Peter Harman has developed a nice format some years ago, it's the Recon format. And if this is extended with more metadata, clue particles, and some other things, maybe this is the right way to go for Modelica. That in the end, every Modelica model, Modelica, FMI, SSP at the end has results stored inside a model, and all the tools that get it can automatically test whether what they get is the right thing. Then in order to do this, you have to define a scenario definitions and results. So not only the format, but how you define scenarios, so the inputs and what you expect to get, which tolerances you use in the integrator, and which tolerances you expect in results, so that you get automatic reproducible tests for every provided model and much more. And just to link, I'm pretty sure Martin Benedict from Virtual Vehicle, who is heading this UPSIM project, at some point in time will just also initiate that we get closer in contact, so that also people not in the UPSIM project can give their opinion and get early results. So Modelica Association members and tool vendors. Okay, thank you.